Alright, I'm just going to do a short video where I run a couple quick, just 1.4 examples. 1.4 is this complex number arithmetic, and so the sort of new information is that we're defining I to equal the square root of -1. What that means is then if I take I and I square it, well, that would be the square root of -1 squared, and the square root squared of something would get us back to the original. So I sort of need this imaginary number, right? We've sort of said many times before you can't really take a root of a negative number. So we're using this I as sort of a placeholder variable, as sort of a what if we could do this, what would happen, and then thus we get sort of a generic complex number, and it's going to take the form a plus b times I. So you might write z as the number, and it would consist of a plus bi, where a and b are just any real numbers. So for plus minus, all we're going to do is combine like terms. So if we're adding and subtracting, that's all there is to it. For example, right, if I did 3 plus 2i and I added it to 7 minus 3i, what we'd end up with, just combining our like terms together, right? 3 and 7 would be 10, plus 2i minus 3i would be like minus 1i. So we might write this as 10 minus I. If we're going to do a subtraction, it's almost as fast. 5 minus 6i, let's subtract away. 3 plus 4i. So what we need to do if we're subtracting is just make sure we sort of distribute this negative, right? This would really be the same thing as 5 minus 6i, and then if I distribute my negative, this would be like minus 3, and this would be minus 4i. So then when I go to combine like terms, I just have to watch my signs a little bit. 5 minus 3 is going to be 2. Minus 6i and minus 4i in total would be minus 10i. And that would be what we have. So this is going to look a lot like the kind of arithmetic when we're trying to sort of add, subtract, multiply, divide polynomials, right? Because if we have this sort of a plus bi, this sort of like two-term number, this is the same kind of things that happen. So if we're going to multiply, we'll FOIL or use the box. So if, for example, we take the same kind of number, 3 plus 2i, let's just multiply 7 minus 3i, right? I mean, why not? Let's just kind of use the same thing we just did. So if I set this up, so this is going to become then 3 plus 2i, 7 minus 3i. If I actually do this multiplication, what do I get? Sort of term by term, right? 3 and 7 is 21. 7, 2 would be 14i. 3 and 3 would be minus 9i. And then this is interesting, right? 2i and minus 3i is going to be negative 6i squared. And so what's going to happen for us here is if I do negative 6i squared, this is negative 6 times -1, right? So the I squared becomes a -1. So negative 6 times -1 flips the sign and makes this into a positive 6. And it drops the I off of it. So this is going to become kind of term by term 21 plus 14i minus 9i, and then this plus 6 on the end. So what would be, if I was sort of foiling, my sort of first and last terms actually both become real numbers. So if I square the I just get a -1. So then as far as combining like terms, 21 and plus 6, well, that's going to be 27. 4i minus 9i, 14i. What are we going to be left with? 5i. Like so. So multiplication is just a matter of sort of foiling or doing a sort of box multiply setup. You're good, Soph, don't worry. The numbers aren't going to come mess with you. For division, what we're going to do is we're going to use what we call the complex conjugate. So if you've got a plus bi, the conjugate is going to be a minus bi. So same numbers, you're just flipping the sign, or flipping the operation from plus to minus. If you started with a minus bi, well, then this would be sort of a plus bi. So the conjugate is sort of the same terms, you're just flipping the operation in the middle, plus to minus, and vice versa. So division is going to look like, well, let's do 3 plus 4i over 2 minus 3i, something like this. So the idea is we can't necessarily just sort of divide 3 by 2 and 4 by 3. It's not going to work that way. And so what we're going to do, rather than do that, we'll sort of parenthesize both of these guys, and I'm going to multiply top and bottom by the conjugate of the denominator. So I'm doing this sort of particular multiplication. So in this case, right, our original bottom is 2 minus 3i, so I'll flip it. I'll do 2 plus 3i, and I'm going to multiply top and bottom. That's going to give me, so on the top, right, I'm going to have 3 plus 4i times 2 plus 3i. If I do a quick little kind of like FOIL, right, 3 and 2 is 6. 3 and 3i would be 9i. 4i and 2 would be 8i. And then 4i and 3i, so it's going to be plus 12i squared. But, as we just said, right, that's going to become then minus 12, right? Because I squared is going to be like a minus 1. So this is 6 plus 9i plus 8i. And then we can keep going. So this is going to be 6 minus 12 becomes for us negative 6. 9i plus 8i is plus 17i. So that's our top. Bottom, so this is 2 minus 3i times 2 plus 3i. So the bottom has a sort of interesting property where when we sort of multiply and FOIL this out, 2 and 2 is 4, right? 2 times 3i plus 6i. Negative 3i and 2, that's a minus 6i, so plus 6 and minus 6. Those guys are actually going to cancel each other out, and then we're going to get this, so minus 9i squared. So two things happen. The I terms in the middle cancel out, and then this, right, I squared becomes minus 1. So this is really like 4 plus 9. So the bottom is really like 13. It's just the number 13. So very unexpectedly, this is going to look like negative 6 plus 17i, just like over 13. And so what we're going to do for our final form is just break that up into two fractions. So negative 6 over 13 plus 17 over 13i. So this still kind of maintains this kind of a plus bi form, right? The a here is just this negative fraction, and our b is this positive fraction with the I attached. So complex number arithmetic, no big deal.